Hi, I'm Justin, and I'm a senior backend engineer in the self-serve tribe. And today I'd like to talk to you about staging environments. So here's a quick summary of what I'm going to talk about. First, I'll talk about my personal struggle with testing code. Then I'll get into what are staging environments? What unmet need do they fill? How can you set them up for your backend service? And what can you do to keep your staging environment from getting stale or going out of sync with your production environment? There's a comprehensive guide for setting this up, which I've linked to here. And also, if you have questions, you can ask in the Slido at the bottom. Okay, so let's kick it off with discussing my personal struggle with testing code. So, um, ever since I joined Spotify, I've sort of continually run into this problem where I need to, I get a feature request and I'm working in a microservices architecture. So there's a service that's wrapped by a view service that is in turn wrapped by a front end. And so in order to implement the feature, my first step is to deploy to the service. So I write my feature code, I write tests for it and everything. I get it reviewed as I'm supposed to. And finally, I merge it into the service. Then I do the exact same thing for the view service. And this time I also have to make sure it's ITGC compliant as well. And once both of those PRs are merged and approved, I'm finally able to test my code through the front end. And when I do that, hopefully it works, but sometimes it doesn't work. And sometimes I even have to go back and refactor my service code. And this seems like a lot of excess work. Um, and this is what I would call a long dev cycle, because we make some changes to the service and we don't know that they work until we get to a much later phase. And when we think we're done with our service code, but we're not. And this could be due to something that is either within our controller or not within our control. For instance, a case where it's not within our control is, what if when I'm writing my front end, someone comes in to review my front end PR and they say, hey, you're not using a good protocol here. You should be refactoring the schema of the API. And in order to do that, sometimes I have to refactor both the view service and the service within it. And that requires rewriting all the code, or some of the code at least. Other times it's just an error of my own that causes it to not work. But either way, it's a delay. So the question I ask myself is, why am I pushing code to production before I know it works? I'm doing it because I don't have any other way to test it end to end. And this has a bunch of side effects. One of them is I have to do multiple code reviews. I have to write tests more than once. I have to do extra deploys. And finally, there's this other side effects, which I would call prod code pollution. Now, that is when you have code that you're sending to production and that you're putting in your quote master code base that has not been tested or vetted fully and that you're not certain works. So I asked myself, what if I had a different workflow where I could push my code, I could write my service code, I could write my view code, and then I could push those changes to an imaginary staging environment and I could test them through a front end, a staging front end. And before I get any reviews at all, before I do any ITGC things, this is a short cycle. And it also means that when I finally get it working, when step 5 succeeds and I go to step 6, I can be very confident that the PR that I'm submitting to my colleagues is a good one because I've already tested it. And that means they don't have to review it twice. So how do we achieve that? That is through staging environments. But what is a staging environment? I would define a staging environment as a near replica of your production environment. So your production environment ideally should be isolated from your staging environment so that one does not affect the other. For example, if your service has stateful resources, such as databases, queues, or storage, you would want to have replicated copies of those for the staging version. When I say replicated, I don't mean replication. I mean, there should be a separate database, a separate queue, a separate storage, and they don't necessarily have to have the same data. In fact, it's better often that they don't. And that all you're copying is the schema of the database. You don't need usually the same data in staging and prod. Here's what this looks like in a diagram. On the left, we have production. On the right, we have the staging service. And so both of those have their own stateful resources, the DB, the storage, and the queue. And let's talk about downstream services a bit now. So many services call other services. And so I would break those up into two different types. There's read-only services and there's read-write services. Now, the read-only services, I would argue that you don't need a separate staging copy of those services because you're not, when you make a staging call to a read-only service, you're not actually affecting that service. So production can't be affected. The only way it could really be affected is if you actually hit it with a high volume of requests and took it down or something. But it's not as likely. What about the case of read-write services? So the risk here is if you share a read-write service with production and staging, that means that staging could write something and production could read it. And all of a sudden, your staging environment is affecting your production, which means that the wall of isolation between them is not being honored. So that can happen, but a lot of the times, if your service happens to be a key value type service with a UUID that is keying it, this won't happen in practice because the staging environment will be generating its own UUIDs that are distinct from the production UUIDs, and so they won't collide. So in that case, often, even though it's a read-write service, it can share the same production service. You just have to think about it a little bit and see how it's being used and if staging can affect production. Okay, the next question I'd like to address is why implement staging environments? So the goal is to provide a place for devs to test their code before they send it to production. And these tests should be end-to-end tests, not just the normal types of tests that you can do with automated tests. Another is to catch bugs before they're shipped. And a third is to enable pre-production demos. We don't want to have any also pollution of the data in prod. This is an important point because just like you want code isolation, you also want data isolation. An example of this is if in Ad Studio, we don't want to have an ad trafficked every time we test the system. That's an example of data pollution if that happened. Another thing about staging environments is that they are kind of affected by this concept of a network effect. So the more staging environments you have, the more useful they are. If you only have one staging environment, then you're not that much better off than you would be if you were just testing locally, because when you're testing locally, you have your service running, and it's more or less the same as running staging. Where you get a big benefit from staging is when you have more than one service in your microservice architecture, and all of them are in staging, and they're all talking to each other inside of staging. Now, if you have this sort of setup, you can really do end-to-end tests of multiple services together in tandem. So here's what that would look like. On the left, we have production. On the right, we have staging. And at the bottom, there's a developer who is pushing code. They have a feature change they want to make to asset service and the API service. So first, they push it to the staging environment. And once they've done that, they act as an internal tester, as on the top right. And they'll go in through the front end, and they test to make sure that their changes are behaving the way they expect. After they do that, they're free to push their code to production. So now I'm going to step back a bit and talk about how we test at Spotify more broadly. I've already talked about staging environments, but what other ways do we test at Spotify? The first is locally. We run our code locally. Now, this is the most basic way to test. You just spin up your IntelliJ or whatever you prefer to use, and you set breakpoints in it. You run debuggers, whatever you like to do. This is usually something that we do very early in the coding process to make sure things work. A drawback of running locally is that it's not very good at all for end-to-end tests of multiple services. And the reason for that is that it's difficult to spin up multiple services locally. And even more difficult to have them all talk to each other. It will take up a lot of resources on your computer, and I've never really seen anyone successfully do this. Another problem with it is that often these services need to talk to authentication, and that doesn't work locally. Another problem is that they often have, the repos that we deal with often have complicated instructions for setting up a local test. I've linked to two repos that are examples of that. And the worst part about that is that every repo often has different instructions. So what that means is that we have, not only is it hard to do, but also it presents a barrier to collaboration among squads, because what it means is that a developer on one team, one squad, cannot try to make changes to the code of another squad's repo, because if they do, they won't be able to test that code. They can't even run the code, and no one has any confidence to be able to write code in a repo that they can't even run, I've found. So that's the drawback of that. Secondly, let me talk a little bit about automated testing. So this has a huge number of benefits. To start off, you can systematically cover all use cases. You can describe the expected behavior of the system. And finally, it's great for regression testing. And by regression testing, I mean if we change the code, the tests break. And which tests break tell us exactly what functionality and behavior we have affected when we made that change. So very valuable. The drawback of automated testing is that end-to-end automated tests are slow and hard to maintain. And you can see this. This is reflected in the testing pyramid, which is shown here. The topmost triangle in that pyramid, it's called integrated here, but it's actually the same as end-to-end tests. And the reason it's the smallest is because we're supposed to have the least number of those and the most number of unit tests. Although some people also call it the test honeycomb, which is another model. And arguably, you could have less unit tests and more integration tests instead. But either way, you're going to have very few end-to-end tests in either of these two diagrams because the top triangle is small. So it's not very effective for this case of end-to-end tests. Another factor to consider is that unit and integration tests don't provide a good alternative to end-to-end tests. They don't tell you if you're breaking the upstream caller to the service because it's not end-to-end. Finally, they often mock things out, which reduces the realism of the tests. Now, I'm not saying you shouldn't write tests. Write as many tests as you can, but just acknowledge and recognize that they have blind spots, and it's important that we have other ways of catching those blind spots before we send stuff to production. Thirdly, I like to talk about manual canary testing. So this refers to sort of what we call the canary in the coal mine. This is an analogy which we use to describe when we send code to only a single instance of a service, whereas there might be 20 or 30 more instances that we're not sending the code to. And if the error rate is elevated on that one instance, if it's more than the others, then we decide that the canary died and we don't want to ship that code. But if there's no elevated error rate, then we can ship it. And to ship it, we click continue next to manual judgment, as in this picture. So a great benefit of manual canary testing is that it's very realistic because we're using it on real data and real customers and its production. The drawback is that we're actually experimenting on real users, which means that those users, if the code that we've sent that we haven't tested completely is bad, that means we could hinder the experience of a certain percentage of our users. Another problem is that in some cases, you don't have enough traffic for the data to be meaningful, the error rates to be meaningful. For instance, in Ad Studio, we don't have as much volume of users as the end user site of Spotify does because our users are advertisers and there's not as many of them. So we might have to wait a long time to determine if there's actually an elevated error rate. Another problem is that when we deploy code to a canary, we're actually merging it to master. And that amounts to polluting the master code base with code that we're not sure it worked. If we were sure it worked, we wouldn't be sending it to Canary, right? Um, and but this has some very dangerous side effects. For instance, what if there is a PD incident, a PagerDuty incident in the middle of the night at 4 a.m., and you have code that is in manual judgment phase or is otherwise just not rolled out, but it's still in the master code base. Now, the person who's fixing that, they might need to make a PR to fix the problem at 4 a.m., and they're about to roll that PR out, but then they realize that there's some code that is in master but not deployed, and they have to figure out what to do with that. They can roll it back, or maybe they'll call you at 4 a.m. and wake you up and ask what they should do. And hopefully they don't do that, but if they do, it's your loss. And whereas ideally we would not have code in master that is not deployed. Um, Another problem is that we can actually forget to press deploy. We can forget to click this button, continue here. And what happens then is that the code just never gets merged. And here's an example of that. This was actually not done with canaries, but there's other manual features that cause this to happen. So this repo is set up to only deploy manually. And as a result, these PR bots merged their code over a month ago, but it still has not been deployed. And that's a problem, because what if these PRs were really important? What if there are security fixes and the org might think that this has been rolled out because it's merged to master, but in fact it has not been rolled out. So this brings me to the concept of continuous deployment, and that is the CD in the phrase CI/CD. What does it mean anyway? So what continuous deployment means is it means you're automatically releasing a developer's changes from the repository to a production. And this is valuable for precisely the reasons I just described in these past two slides. If we don't do this, we end up with situations where code in our code base does not match what's deployed, and all sorts of problems ensue as a result. Fortunately, Infra has come up with a better way to do this called automated canary analysis, ACA. And the benefit of that is it actually does achieve continuous deployment. The way it does it is there's actually a bot that will measure the error rate of your canary over a certain period of time. And if it's low enough, then it will deploy it. So this will ensure that your code is automatically deployed or rolled back if it fails. Either way, it won't be left in limbo. So it's worth noting that a drawback of this is that we're still testing it on real users. And furthermore, if I was a dev who was trying to personally test my code manually, I wouldn't choose this way, because you would never know when your automated canary might suddenly decide to deploy itself. And if I was trying to manually test it myself, this would not be something that I would like, because I would want to choose when the code goes out. 4, rollout flags. This is another way we test code. And what we're doing essentially with rollout flags is there's a platform called experimentation platform where we declare flags. And these flags are fetched by our services, either our front end or our back end, and they're used to determine if the user should receive a certain test behavior or not. And this is great because it allows us to experiment, to explicitly define the set of users we're running our tests on. So it fixes the problem the canaries have of testing on real users. And this, instead, we could make it so that only the developers are receiving this. The drawbacks of this are that, one, it litters our code with flag checks, and it becomes unmaintainable if it's overused. Also, if you're trying to do a code refactor, forget about it, because you can't wrap a code refactor behind flags usually. It's just too complicated and ugly. Finally, we come to staging environments. This is the one that I'm the subject of this conversation, of this talk. So the benefits of staging environments are, one, that you don't have any code or data pollution at all. And that's because we're actually sending code to a different branch besides master. 2, realistic end-to-end testing is finally possible because we have systems all working together in an integrated environment. 3, the procedure for testing is the same for all repos. So we don't have the problem that local environments have anymore of like every repo having a different procedure. The procedure is simple. All you do is merge your feature branch to staging and push it. Drawbacks. So unfortunately, staging environments, they do have to be created and they do have to be maintained. There's an upfront cost to creating them, which is basically creating the stateful resources associated with them and creating a separate component in Backstage, etc. There's also problems that can arise in staging, like it could go down and people ask you why it's down and you have to look into it. Another drawback people bring up sometimes is that you have to merge your code, every code change, to two branches, which amounts to a complex deploy procedure. But I have a fix for that, and I'm going to get to that later. So here's a comparison of the 5 testing methods I've shown you. I'm trying to point out the strengths and weaknesses of each, and I've highlighted 2 columns here because these 2 columns, end-to-end testing and prod code pollution, these are 2 cases where I feel that staging environments provide a unique benefit that none of the other testing methods provide. Now, this also calls attention to the fact that all of these testing methods have their own uses. Like, nobody's going to tell you you shouldn't write automated tests or use canaries or rollout flags or local testing. They all have their own unique benefits. But so what we're saying is that staging environments are a great supplement to those other 4. So how do you set up staging environments? Let's get into a new section here. So staging environments follow a branch-based deploy model, typically. So when you merge your code to master, it deploys to production. When you merge it to staging branch, it deploys to staging, as in this diagram. So I'm going to show you what this looks like in your build info file. This is an additional section of code in the build info file that you would need to add. It looks ugly here, but it looks a little better in an actual IntelliJ window, I promise. So what we have here is a pipeline. It's a custom pipeline we're adding. And this pipeline has 2 components. First, the staging build component, and then the deployment component stage. Another thing I should call attention to is this ref : staging. What that refers to is it's basically saying whenever you merge to this branch, staging, this pipeline is triggered. And so you can essentially define that branch to be whatever you like, but I like to use staging for consistency. The second thing to mention is this dskip test flag that I have down here. Now this is really nice because it causes your staging environment, when you deploy to it, it skips the tests. And often when you run with tests, it can take 15, 20 minutes, but running without tests is only 3 to 5 minutes. And it's okay to do that because our PR build already requires test to pass and master requires test to pass. So it's a bit redundant to have staging require it too. And what's great about that is if you want to iterate quickly on changes to staging, it's much faster than trying to do it anywhere else. So let's look at what the staging development workflow looks like. So you write a feature change in a feature branch as usual. When you're ready to test it, you merge that to the staging branch. Then you test it in the staging environment. When you're satisfied it worked, you merge your feature branch finally to master. And one thing that's really cool about this is that multiple developers can actually use the staging environment at the same time to test their code and without causing problems. So here's an example on the right here. So Alice is pushing to staging her test feature X. And then after that, Bob pushes their test feature Y to staging. And usually there's no conflicts because they're usually not working in the exact same area of code. But if there are conflicts, Bob resolves them. And both of their changes get merged to get deployed to staging. And they can both test independently without even knowing each other are there, their changes in staging. So what are some of the challenges of staging environments? So when I proposed this in Ad Studio, I got a lot of pushback. And this is what it sounded like. People said things like, that sounds great, but now I'll have to push every code change to 2 branches. That sounds like a pain. Also, people would say, what happens if some people skip staging and branch deploy and they go straight to master? Then what you have is a staging environment that no longer reflects prod because it's missing some of the code. And this is bad because it can break upstream callers to that staging environment, which some of those callers might assume that staging has those changes and it doesn't. So that's a problem. A third problem is that fleet shift PRs will need to be duplicated for staging because they're currently only issued to master. And it would be a major pain to have to manually create all those PRs of fleet shift PRs into staging as well as master. So I looked for a solution for this problem. And what I found was that there was a common pattern among all these complaints, which is basically what people are describing as a system that lacks backward compatibility. So we often talk about backward compatibility in the terms of systems, right? So one system is not backward compatible, we say, if it does not support the old version of another system. Well, we can also talk about backward compatible processes or workflows. So a dev process is not backward compatible. I would define this as if some developers follow this process and some do not, then it shouldn't create chaos. If it does create chaos, then it is not backward compatible. So my question was, how could I rejigger this process so that it is a backward compatible process? And I came up with this idea of cascading down merge. So the way cascading down merge works is that when you merge code to master, it also gets auto merged by a bot to staging. Now it's a backward compatible process. So here's what happens. In the old workflow, a dev who doesn't know about staging might just merge their code straight to master. Or even if they know about staging, they might just not care about testing it. Like for instance, if it's a documentation change, they shouldn't need to test that, right? So anything they don't need to test, they can just send straight to master. And then our bot will see that and it will pick it up and merge it to staging as well. And as a result, that code gets deployed to both prod and staging environments. The second workflow, the newer workflow dev, who actually wants to test their code in staging, will just merge their code to staging, and that should work fine. And both of these workflows can coexist without breaking each other or breaking the system. So here's what it looks like in a diagram. Now I presented this diagram before, but it did not have the blue portion. So the blue portion is basically indicates master changes cascading downward to staging. And what's really cool is that if you have 3 environments, you can have it cascade down to all 3. So a master change will get to staging, which will get to dev, or even 10 environments it will work. This model is expandable. How does this work? So I created this thing called a down merge action container. So action containers are things that you can put in your build pipeline that basically run some sequence of commands. And so in this case, the sequence of commands are as follows. When master is built, it does the following. So it tries to merge the master code into staging branch. If there's not conflict, then it will push the changes. If there is conflict, it will actually reset staging to match master, and it will force push to staging. That sounds a little scary, but it's actually exactly what we want if we think about it. So here's the upshot of this. So usually multiple people can test in staging at once without affecting each other. But if a master merge conflicts with the code that they have in staging, master will win. So it will overwrite it. And the staging code gets reset. So this can seem like a pain, but for one thing, it's not that common for the code changes of multiple people to conflict, fortunately. And for a second thing, there is a remedy to this, which we discovered, which is this feature pin in Backstage. So what a tester can do if they really don't want to risk their code being reset while they're testing it, is they can mark it as pinned in Backstage. And if they do that, then even if someone merges to master, that code will still go into staging branch, but it will not cause a redeploy until this person unpins the version. So it really protects you against that problem, but it still keeps the code in sync at the same time. All right, so this is what concurrent testing looks like when you have this cascading down merge. So Alice and Bob are doing their usual merge stuff, which I demoed before. But addition here, we have Charlie, who's also merging code to master. And here you have a bot that is syncing the master changes to staging. And what we have as a result is that Charlie's changes are going to production, as in 4 here. And in 6, Alice, Bob, and Charlie's changes are all going to staging. Here's a quick demo. which I'm going to show you. First, I'll demo what it's like to merge to staging, and then I'll show you what it's like to merge to prod. So first, for merging to staging, all you have to do is you take your feature branch and you do git merge into sandbox. Now I'm calling it sandbox, but it's actually staging. It's just different things have different names. This repo calls sandbox staging, but so just ignore that difference. So git merge, the demo changes, and then after that we push them. As soon as we push them, we see in our staging component in Backstage, we see it start to build. And in a minute or two, it's deployed. But what has happened in production? Nothing, because we have isolation between staging and prod, so we don't have to worry about anything breaking. The second demo is what happens when someone merges to master. So in this case, the thing that's merging to master is a bot. So it merges to master. Then we have a build of master that immediately starts. Next, we have the sandbox. About 100 seconds later, actually, if you look at the timing on this, the sandbox build starts. And it starts later, but it actually finishes first, which is cool because it skips tests. So it's also worth noting that the build is called auto down merge. It has just this arbitrary name to indicate that it's a down merge. So here's what it finally looks like when it's deployed to staging. You'll notice that there's something called copycat bot. That is a bot that I've used to sort of simplify the permissioning of this. And so basically that allows us to not have to create new secrets every time we add a repo to this process. So it's worth noting that this might look like it's polluting your Git history, but it's actually not, because it's only creating these auto down merge commits on the staging branch. It never changes master. So, and every once in a while, staging gets reset. So in reality, all of these auto down merge commits eventually go away. And finally, after staging is deployed, then master is deployed, prod is deployed, and we're done. Here are some testimonials of people who have used the system and were happy with it. I won't read them all, but you can look at them later.